Now that we have a sense of what the linearization is, or linear approximation, let's go ahead and do example 2. So question A says find the linear approximation for f of x equals tangent x at p equals pi over 4. So that means for question A, what we're looking for is we want to get this function L of x, which is equal to f of p plus f prime of p times x minus p. They tell us that p equals pi over 4. Then f of p will just equal tangent of pi over 4, which is equal to 1, because sine of pi over 4 is square root of 2 over 2, and cosine of pi over 4 is also square root of 2 over 2. So when you do sine over cosine, you get 1. Now f prime of x, when I take the derivative of that, I get secant squared of x. And if I now plug in p, I get secant squared of pi over 4, which is 1 over cosine squared of pi over 4. And cosine of pi over 4 is the square root of 2 over 2. And I'm now going to square that. And this comes out to being square root of 2 over 2. When I square that, I get 2 over 4, which simplifies to 1/2. When I multiply by the reciprocal, I flip over that 1/2 and I just get 2. So f prime of p is equal to 2. So my L of x is equal to, let's see, f of p is 1, f prime of p is 2, and then I get x minus pi over 4. And I could multiply the 2 through here, but it wouldn't really make the equation any easier or look any nicer, so I'm just going to leave it like that. That's my L of x. Now question B says determine the values of x for which the linear approximation is accurate to within 0.1. So here's the idea. This L of x right here, we're saying that that's pretty close to the function tangent x when we're close to the point p equals pi over 4. And as you get further away from pi over 4, the linear approximation no longer becomes terribly accurate. So we're trying to figure out how far from this point pi over 4 can we go and still be accurate to within 0.1. And to do this, we're going to have to pull up a graph. And we're going to graph these three things. Well, let's just we'll graph 1 plus 2 times x minus pi over 4. That's my y1. For y2, I'm going to graph, maybe I'll just graph tangent of x and see that these two are, in fact, this is actually a tangent line for tangent x. And then I want something that's slightly bigger than tangent of x. I want to do tangent of x plus 0.1, because that's the distance I want to be within. And then y sub 4 is tangent of x minus 0.1, because I could be off by being above the function or off by being below the function. And let's go ahead and see what that. So I'm going to start by typing in my linearization, 1 plus 2 times x minus parentheses pi divided by 4. And then I'm going to do tangent of x. I'm going to do tangent of x plus 0.1. And I'm going to add one more equation, tangent of x minus 0.1. And that graphs all of them. All I'm really interested in, though, is this area right here close to that spot. So I'm going to zoom in a little bit. Drag this over toward the middle. And maybe zoom in one more time. All right, so let's see what we got here. First, let me take these away. What we have here is the green graph is tangent of x, and then the blue line is my linearization. And you can see that they're overlapping, they're touching right at about 0.75, maybe a little bit more. And remember, that's at pi over 4. Pi is approximately 3, so 3 divided by 4 is approximately 0.75, so that's the right spot. And my tangent value there is 1, so it's actually right here At that spot right there is where we're having the tangent line hit. And if I take away the line for a second, I can look at these two, or these three. The green graph is tangent of x, the red graph is tangent of x plus 0.1, and the sort of orangish one is tangent of x minus 0.1. So the idea is I want to know, I'm going to now remove the tangent graph and put the linearization in. And my question is, how far can I get from this spot where the line was hitting at y equals 1 before I'm hitting either one of these graphs? And it looks like the two spots where it hits are both on the lower one. So what I really want to do is figure out what is my x value here and what is my x value there, and I can say between those two x values, my line and the graph of tangent of x are within 0.1 of each other. So I could just trace the graph and get an approximation, but this actually has an intersect feature. So it asks me to select the functions, and I'm going to do tangent of x minus 0.1. And then I select here and I drag it over, and then it tells me that point is at x equals 0.525. That's the x value where I'm off by 0.1 with my linearization. And I can do another one up here, and it tells me it's at 0.97855. So now I can go back to my my PDF here, and the result from my graph, so the graph basically, we had something like this, we had a line, it was hitting at 2 points, there and there, and those x values were 0.525, that was the one down here that we found, and the one up here was 0.979. So I will say on the interval 0.525 to 0.979, the linearization L of x is within 0.1 of f of x equals tangent of x. And that's my answer for that question right there.